This is our third video on time value money. First one we talked about the fundamentals, kind of the math behind it. The first one we went through all kind of the basic time value money problems, present value, future value, solving for our interest rate, solving for n. This one we're going to talk about annuities. And then we'll have a fourth one where we talk about how to use some other buttons on your calculator. So let's look at this first problem. If you put $100 away at the beginning of each month into an account that earns 8% interest, how much will you have in 30 years? So there's a couple things going on in this problem that are new that we haven't done in old problems. One, we're going to have the payment key involved because this is what's called an annuity, where you have a set payment that happens every period. That's that fifth button, that fifth gray button on your financial calculator is for that. That'll be the $100. Another thing that's different about this problem is that we're in months, beginning of each month. So far we've had everything in years. When your interest rate is stated, it's stated as annual. We always state interest rates annually. So this is 8% interest. That means 8% a year. In order to get your calculator to work correctly, you have to have all the middle, let me flip over to our little graphical chart here. I've already put the numbers in here. But N, payment, and I/Y always have to be in the same time units, these three middle ones. So if you're in years, it needs to be number of years, payment per year, interest per year. If you're in months, it needs to be number of months, payment per month, interest per month. If you're in days, it needs to be number of days, payments per day, interest per day. The key is these three all have to be in the same time units. So in this problem, it said you're going to put $100 away, that's our payment, for 30 years, but those are months, so you got to take 30 times 12 is 360 months. So you're going to have 360 months of a $100 payment at an 8% per year interest rate. On these problems that we give you in this class, all you have to do is just divide by 12. Technically, you can't divide and multiply interest rates by a number because of compounding. We're not going to worry about that in this class. Just take whatever number is given to you, divide it by 12 to get interest per month. So if you divide that out, it's actually 2/3. So you're getting 2/3% per month. You're paying in $100 a month for 360 months. Now you can solve for your future value. Present value isn't given to you in the problem. A lot of these problems are problem-solving type problems. It won't always give you exactly what should go into each of those 5 variables. You kind of just have to think it through. In this case, we're paying in $100 a month for 30 years. If year 0 is the initial value of your investment, you haven't put anything in yet. If you haven't put anything in yet, it's worth nothing. So your present value is just 0. So you have 4 of the 5 and we can solve for that future value. So if I plug that into my calculator. Oh, wait, there's one other thing we need to mention. If I go back to the problem, it says you put $100 away at the beginning of each month. That's key, is that there's 2 types of annuities. There's what's called an ordinary annuity and an annuity due. This one specifically says it's an annuity due. Annuity dues are paid at the beginning of the month. Ordinary annuities are paid at the end of the month. It just depends on the context of the problem. For example, your rent payment, your mortgage payment, things like that, insurance, you pay at the beginning of the month. Other things like your credit card bill or your electric bill, at least the way things are set up here in America, we pay at the end of the month. So it just depends on the problem setup, what you're trying to solve for. In this particular case, you're putting it at the beginning of the month. That means it's annuity due. Your calculator is automatically set up for ordinary annuities. If you're going to do an annuity due, you have to change one button on here. Let me pull up a picture of the calculator. Again, I can't show you this real well, but I'll just talk you through it. Right above the payment button, there's a little yellow letters that say BGN. That stands for beginning. That means if you want to change it to beginning a period, you need to hit second and payment. So if I hit second payment, it'll bring up a thing that says END, end. It means it's right now it's set for end of period payments. We want to change that. It says in real small letters up here set, which means hit set to change it. Set's right above enter. So if I hit second enter, it'll change to BGN on the screen, which means now we're set to beginning of period payments. So if I hit just clear in the lower left hand corner down here, it'll take me out of that screen, and now it'll say BGN up here on the upper right, in real small letters, which means we're set for beginning of period payments. And now I can go over to my problem and just put the numbers in. I don't have to do anything else. The math will come out slightly different if you're paying at the beginning of the period versus the end of the period. You'll get almost the same answer usually, but if you want to get it technically correct, you got to change that ending to period to beginning. All right, so let's plug all these numbers in real quick. All right, so when I plug all those in, I get 150,030. Technically, this 100 probably should have been negative because you're going to pay that, and then you'd receive a cash inflow at the end when you withdraw all your money. So you can think of it as, again, different ways to think of it. You can think of it as I'm paying for my kids, planning for my retirement or planning for my kids' education in the future. I'm going to put $100 a month in for 30 years. I'm earning 8% a year. How much money am I going to have at the end of that? This will tell you, 150,000 roughly dollars. All right, let's go do another problem here. This is present value of an ordinary annuity. One thing you always want to do whenever you do a problem where you have an annuity due, make sure, and it tries to warn you, and it says in the upper right hand corner BGN. So if I pull up the calculator picture, it should say BGN up there, beginning. That's to warn you, make sure you go back and change it, because if you don't go back and change it, it'll screw up all the other problems you do from then on out, and you'll get half the problems wrong on the test, if you don't change it. So make sure as soon as you're done with a annuity due, go right back, hit second payment, and then hit second enter, and it'll change it back to, it'll say END on here, which means you're back to ordinary circumstances. Then you hit clear, lower left hand corner, and it doesn't say BGN in the upper right hand corner anymore. So you're back to ready to do typical problems. Okay. All right, let's look at this problem here. You have won a $10 million lottery which pays $1 million a year for 10 years at a 5% required return. That's your interest rate. What is an equivalent lump sum payment right now? A lot of times when people win the lottery, lotteries give options to the winners. You can either receive a lump sum all at once today, or you can receive an annual payment or a monthly payment or something like that. If I were to take $10 million, $1 million and multiply it by 10, I'd have $10 million. When they quote lotteries, how much they're worth, that's how they do it. They take the annual amount you could receive and multiply it by the number of years. But technically, this is not a $10 million lottery. That's an advertising ploy that they do to make the lottery sound bigger. Because $1 million paid every year, if you were to discount all those back to today, it's not going to be worth $10 million because of time value of money. Because as you discount, you're going to discount one payment back. You're going to receive $1 million in the first year, $1 million in the second year. Each one of those you need to discount back to year zero. So one payment you're discounting 1 year, one payment 2 years, one payment 3 years, one payment 4 years, and so forth. As you discount longer and longer, they're going to get smaller and smaller. So the actual lump sum value today that's equivalent to $1 million a year is going to be significantly less than $10 million. And that's how it always works when you look at the two options they give you if you happen to actually win a lottery, which none of us probably ever will. But if you happen to, they usually give you, and the lump sum payment is significantly smaller than the dollar value that you'd receive if you took the annuity. But that doesn't mean it's not worth as much, because you have to consider time value of money. The fact that $1 today is worth more than $1 in the future because of discounting, because of the interest rate. So if we go over to our chart, we're asking for the lump sum today. That's your present value, so I put a question mark on present value. It's an annuity that pays 10 years, so N is 10, $1 million a year. So payment is $1 million at a required return of 5% a year. So I/Y is 5. Future value is just 0 in this case, and that one's a little ambiguous if you read the problem. What do I put in for future value? The way to think of that is you're receiving $1 million in year 1, $1 million, and each year you're receiving $1 million. You'll get $1 million in year 10 as part of the payment. Are you going to receive another payment? And the answer is no. All you'll get in the last year is $1 million. Future value, if there was a future value, that would mean that there's another additional payment that's paid in year 10. And a lot of times that happens with bonds and things like that we'll talk about later. But in this case, that doesn't happen. Another way to think of a present value is it's like a price. How much should I pay to get all these cash inflows in the future? Well, you're going to get 10 cash inflows of $1 million. You're not going to get an additional cash inflow in the last year. So this is the way you set this up. We'll plug all this into our, and I'm getting an answer of 7.7 million, or negative 721 735, if I did it right. 5% is a relatively low interest rate. The nice thing about a finance calculator is, let's say I wanted to do a sensitivity analysis and decide, what if my interest rate wasn't 5%, what if it was 10? Well, you just you do 10, hit I/Y, and then recompute your present value. In that case, it's only 6.1 million. So it gets smaller as the interest rate goes up. We'll talk about that dynamic later. As interest rates go up, prices go down, and vice versa. When interest rates go down, prices go up. But with a 5% interest rate, that means you'd be indifferent between receiving $1 million a year for $10 and receiving one lump sum payment of $7.7 million. Those two are equal to each other in terms of time value money. Alright, this last annuity problem here, and then we'll end this video and we'll start a new one, is on solving for the interest rate of an annuity. It says for $10,000 you can purchase a 10-year annuity that pays $100 per month. What interest rate are you earning? Again, this is I've kind of tried to set these up to make you think. This one only gives you three numbers: $10,000, 10 years, $100 per month. You should have four numbers, so you need to figure out what the other number is. What are you solving for? You're solving for I/Y, interest rate. What interest rate are you earning? Of course, it tells you up here at the top, solving for interest rate. But what interest rate are you earning means I/Y is where that's a good starting point. That's where your question mark goes. What are the other ones? Well, for $10,000 you can purchase. That means your present value is negative $10,000. You can purchase a 10-year annuity. These are, so N should be 10 years. But notice it's per month. And payment and interest rate all have to be in the same time unit, so it's going to be monthly. So it's not going to be 10, it's going to be 10 times 12 is 120 months. And then payment's going to be $100 per month. Alright, let's switch over to... So here's what I have set up. Hopefully I have it right. But N is 10 years, and we're in months, so we got to multiply it by 12, that's 120. Payment's $100 a month. You're going to pay $10,000 for this annuity. Future value in this case, again, is just zero. That's the one that wasn't given to you directly as a word. You kind of just have to think it through. There's no additional payment in the last year, so there's no future value involved. The interest rates are what we're solving for, but we're solving, in this case, we're in months. Interest rate's going to be in months. So we're going to need to multiply it by 12 after we solve for it. Let's plug all this into our calculator. Sorry about that. Hit the wrong button there. When I plug all that in, I get 3.74%. But we need to multiply that by 12. So we usually don't state interest rates in terms of months. We state them in terms of years. Oh, I'm sorry. I got 0.31%. Sorry, making a lot of mistakes here. 0.31%, which when multiplied by 12 is 3.74%. That's what I meant to write there. Sorry, having a little Microsoft Word issue here. 3.74% is our final answer. That's our annual interest rate we'd earn if we pay $10,000 for $100 a month for 10 years. So you have to ask yourself the question, is that a good enough return or not? 3.74% is pretty low. Here right now in the U.S. we have a very low interest rate environment, so that might actually be a decent return. Typical conditions, though, that's pretty low interest rate. So, but this at least gives you a way to give you an interpretable number about these dollar values. Is this a good investment or not? This tells you, well, you're going to get 3.74. You take that 3.74, you compare it to other investments and say, Go out and look at treasury bonds, corporate bonds, things like that. All right.